Good day everyone, and welcome to this presentation on web application security. Right, so web application security is all about protecting websites and online services from threats and attacks. So secure coding practices are essential. Secure coding practices are also essential. They help developers build applications that can resist attacks, protect sensitive data, and ensure the application works as intended throughout its entire life cycle. So, for example, if a banking website is not secure, hackers could steal money or customer data. That's why security must be considered from the very beginning of development, not just at the end, right? So by understanding some common vulnerabilities and implementing strategies to mitigate them, developers can protect sensitive data and maintain the integrity of the applications throughout the software development life cycle. Let's look at some key secure coding practices with the real-world examples. Then we can talk of input validation. This one always checks and clean data from users. For example, if a form asks for an email address, make sure it really is an email and not a piece of code, right? Then secure database access. This one you can make use of parameterized queries and prepared statements, right, to prevent attackers from injecting malicious SQL commands, right? For example, instead of building SQL queries by joining strings, use placeholders for user input, right? Then under the secure database access, so we have a database encryption. This is encrypting sensitive data like credit card numbers so that even if attackers get into the database, they can't read the data. Then, still under secure coding practice, we have output encoding. This encoded data before displaying it in the browser to prevent attacks like cross-site scripting, right? Then we have secure error handling. This one, make sure that don't show detailed error messages to users. Otherwise, attackers might learn how your system works from those errors, right? Then there is memory management. This is proper managing memory allocations and bound checking, right? So this one in languages like C or C++, always check the size of data before copying it into memory to avoid the buffer overflows. We have security testing and code review. So regular test your code for vulnerabilities and have other review it. Then avoiding third-party components. Only use trusted libraries and frameworks because insecure third-party code can introduce vulnerabilities. Then we'll move on to widely used secure coding standards. We have SetC, C++ coding standard. This one provides guidelines for writing secure and reliable C and C++ code. This provides rules for writing safe and reliable C or C++ code, which is important because these languages are prone to memory errors. Then we have the OWASP Top 10. This one is a list of the 10 most critical web application security risks, like the SQL injection and XSS, with advice on how to avoid them. So every web developer should know this list, right? Then there's language-specific guidelines, right? For example, Java Secure Coding Guidelines or Microsoft Secure Coding Guidelines help developers write secure code in those platforms. So programming languages often provide their own secure coding guidelines, such as Java Secure Coding Guidelines and Microsoft Secure Coding Guidelines, right? Then we move on to web application vulnerability, right? So web application face many threats, and we want to discuss some of the most common vulnerabilities and how they are exploited in the real world, right? So we have cross-site scripting, the XSS. This one happens when an attacker tricks or a website into displaying malicious script. Example, imagine a comment section on a blog. If the website doesn't check what users submit, an attacker could post a comment like, let me give an example of maybe script steal cookies, right? Right? Then when someone else reads the comment, that script runs in their browser and could steal their login sessions, right? So we are saying that this is a web application vulnerability that occurs when an attacker injects malicious script into a web page that is then executed by unsuspecting users. So this can lead to various malicious activities such as stealing sensitive information, hijack user sessions, or defacing website. So to prevent cross-site scripting, always validate and sanitize user input, encode output before displaying it in the browser. Some of these security mechanisms that we will be explaining on each web vulnerabilities, we explained them under secure code. We explained them under secure coding practices, right? So we are going to give a security mechanism on each web vulnerabilities that we'll be explaining, right? Then we move on to cross-site request forgery, the CSRF, right? So this one tricks users into performing actions they did not intend, right? For example, suppose you are logged in into your bank. If you visit a malicious website, it could send a hidden request to your bank to transfer money, and the bank thinks it's you, right? So it's an attack that tricks a user's web browser into performing an intended action on a web application on their behalf. So the attacker typically lures the victim into clicking a malicious link or visiting a website that contains a malicious code. So to prevent cross-site request forgery attacks, we make use of CSRF, cross-site request forgery tokens. These are unique codes that must be included with every request, making it hard for attackers to forge. Then there is SQL injection. This is when attackers insert malicious SQL commands into a query, right? So if a login form directly inserts user input into SQL query, an attacker could enter maybe admin, then dot as a username and bypass authentication, right? So to prevent SQL injection attacks, developers should employ some security mechanisms, and some of them were explained under secure coding practices, right? Under secure coding practices or secure coding, safe programming. So this one you can make use of for parameterized queries and prepared statements. Then apply the principle of least privilege. Don't give the web app more database access than it needs, right? You can make use of web application firewalls and keep software up to date, right? Then there's also regular patching and updates, then security testing. Then we move on to security misconfigurations. These are mistakes in how servers or apps are set up, right? So, okay, when web servers, frameworks, or application components are improperly configured, right, leaving potential entry points for attackers. This misconfiguration can include default settings, unnecessary service, weak access controls, or outdated software versions. So, for example, leaving default admin passwords or enabling unnecessary services can let attackers in, right? So to mitigate this, to prevent this, there is need for secure configuration, right? Then regularly review and harden configurations. Then you also disable unnecessary features and services. Another web vulnerability is a cross-site script inclusion. This happens when a website includes scripts from untrusted sources, right? Such as if you include a script from a third-party site and that site gets hacked, attackers can run malicious code on your site as well. So to prevent this, you use a content security policy to control which scripts can run, right? Another web vulnerability, session management issues, right? So poor session management can let attackers hijack user sessions, right? For example, if session IDs are predictable or not changed after login, attackers can guess or steal them to impersonate users, right? So to ensure secure session management, the developers should implement to generate unique random session IDs, right? And use the secure cookies and always use HTTPS. We can talk of unvalidated redirects and forwards. These ones can send users to malicious sites, right? So unvalidated redirects and forwards allows attackers to redirect users to malicious websites or perform phishing attacks. So to prevent this, you can make use of whitelisting. This is on allow redirects to trusted URLs and also validate all input. Then there is insecure direct object reference, right? This one lets attackers access data by changing a URL or a parameter, right? So these are when an attacker directly accesses internal resources object by manipulating parameters or URLs, bypassing authorization controls, right? So to prevent insecure direct object references, always check that users are authorized before showing data. There's access controls, and also use indirect references instead of exposing internal IDs. Then there is buffer overflow, right? This happens when a program writes more data to memory than it can hold, causing crashes or letting attackers run code, right? For example, the famous Maurice Wem in 1988, right? Then to prevent this, always check the size of data before copying it, right? Use safe functions and memory management techniques, right? Then bound checking, right? So by understanding these vulnerabilities and following secure coding practices, developers can build web applications that are much harder to attack. So real-world breaches show that even small mistakes can have big consequences. So security should always be a top priority from day to day, right? So this marks the end of our presentation, and thank you for listening to the lecture. Thank you.